Okay, now in this question 4 sikhuluma nge-periodic table, as well as ama-concepts involve i-periodic table, your atomic mass, relative atomic mass, protons, electrons, and neutrons, you name it. In the description box is a links for other videos recorded for this question paper November 2018. So lana question 4 but he studied a table below and answer the questions that follow. So element P, Q, R, basipha the number of protons, neutrons, as well as electrons, right? Okay, now we know that the number of protons must be the same as the number of electrons. Protons must be the same as electrons. But check out this one, element R. 16, lana it's 18. So we'll discuss that a little bit later, but I was just pointing that out. But it's not necessary that the number of protons be the same as the number of neutrons. Because of that's why sibanama relative atomic mass, because of the different number of protons as well as electrons. Like 4.1, but it define the term atomic number. The atomic number atomic number is telling a position of e element as well as the number of protons, right? So atomic numbers is defined as the number of protons in an atom of an element. This is the definition of the atomic number. But atomic number iphinde isincede identify a position of a element in the periodic table. But define the number of electrons. 4.2.1 lagu 4.2 but you write down the chemical symbol of element Q using iloganj notation AZX. Alright, as consult the periodic table. Okay, let's do this. Element Q now element Q on a number of protons I14. So we're looking for element number 14 on the periodic table. So it's 1, 2, 3, 4, 5, 6, 7, now 14. Now element 14. So therefore it means our answer is what? Silicone. But basipal as A bateni or AZX. This is the atomic mass, and then this is the atomic number, atomic mass. So lo 28 u A, lo 14 ubani u Z, right? So our answer lana it's silicon 28 14 28 14 u A uyini atomic mass, and then Z the atomic number. 4.2.2 but the element write down the element that is an alkali metal, right? Alkali metal siwathola kuphi ku group 1 group 1 yeah okay asibona la asibona. So sina 11 electrons for element. Also we need to write down between P, Q and R. Between P, Q and R, which one is an alkali metal? So starting with P is born. Let's go back to e table yethu, e periodic table yethu. I think erase la. Element with an atomic number of 11 ubani ukuphi number 11 now 11 ubani sodium. So group 1 ama elements in the group 1 it's an example of alkali metal. So asingayi anywhere further, let's just say our P, element P is our alkali metal, and then Q, but okay, just for curiosity's sake, element 14 now la silicon. This is definitely not a alkali metal. Alkali metal wethu now la. And then 16, element 16, as you check, element 16 oxygen, no, it's sulfur, not silicon, sulfur. So lawa, they are not alkali metals together. So our answer is P. Q no R, they are definitely not alkali metal. So chemical symbol of R 4.2.2 C10. Okay, this one element R 16 angisho, but unama electrons ayingaki I18. I did point this out ekuqaleni. Protons ayingaki I16, but lawa ama electrons ayingaki I18. So it means 4.2.3 element 16 la uphi element 16 nangu element 16 is sulfur, but lo sulfur wethu nama electrons ayingaki I18, meaning una 2 extra electrons. We know that ama electrons nama protons, the numbers must be the same, but this one ina 16 protons and ngaki 18 electrons, meaning una 2 extra electrons. So lena is sulfur, but the answer yethu naila, it's 2s, it's S2 minus, because of ina 18 yama electrons, meaning ina 2 extra electrons. So our answer la is S2 minus. That's the chemical symbol for UR. 4.3 element P reacts with oxygen to form the compound with the chemical formula P2 Naila P2O. Okay, I think erase lana. Let's go back here. Alright, P2O, right? Element P react an oxygen to form P2O, right? And then we identify element P as what? So discover go to element P, it's in fact in sodium. So it means that element P is in the group 1, is in the group 1 periodic table. Now periodic table group 1 now sodium, and then bese bathi ke githi predict la ku 4.3.1 but it predict the chemical formula that element Rb in the periodic table will form when it reacts with ubani oxygen. Mina ngithi it's going to be Rb2O. Why? Because of RB now is in the same group as ubani, as sodium, is in the same group as sodium, right? So it's only logical to say RB naga react an oxygen yoba RB2 na, because they're in the same group. 4.3.2 explain your answer to 4.3.1. I gave away the answer already. So our answer lies that RB is in the same group as element P, therefore the same number of valence electrons. So since RB uyi metal and oxygen uyi non-metal, so then a metal is all nothing in metal in ability to lose ama electrons, right? And then oxygen, since in non-metal in ability to gain ama electrons during a reaction, so therefore 2RB is lose ama electrons, and then lama electrons are 2 as gain ubani or oxygen. 4.4 Slago 4.4 what is the trend in ionization energy as you move from element P to element R? Write down only increase, decrease, or remain the same, and explain your answer. Nangu element P, and then sitheni element okay, it's from P to R. R bani, the R, come on man, the R nangula R usulfur, yes, R usulfur la, right, R usulfur. And then as we move from P to bani to R, so you move from P to R. In other words, I'm moving from metals to okay, let me say I'm moving from group 1. I'm moving from group 1 all the way up to group 6, from group 1 to group 6. But what is the trend in ionization energy? Ionization energy says it's the energy required to remove electrons from atoms, right? So uma move from left to right on the periodic table, the ionization energy yenzani ya increase because of lama atoms, they decrease in size. Because of atoms they decrease in size. So mina lana ngizoti they increase. Since atoms they decrease in size, the nucleus radius yenzani ya decrease nayo. And then the ngathini chakala na example nangu sodium la. This is the atomic structure na nucleus lana, na nucleus of sodium. And then now movela to ubo silicon nabu sulfur, sithi ilo kanje, the size decreases ke manje, uyabona, the radius of nucleus yenzani ya decrease. And then uma it decrease the nucleus radius, what happens again? More energy is required to remove lama electrons because of the attraction between the nucleus as well as the valence electrons or the outer electrons iba much more higher. So therefore kuba difficult to remove ama electrons. Thus the higher the ionization energy. Okay. So lana, the atomic nucleus gets smaller from P to R as I was explaining. Therefore, more energy is needed to remove my electrons because the attraction between the nucleus and the valence electrons is stronger. Therefore, that's why ionization energy yenzani increase. Okay, kube a little bit difficult nyana kuzi express lapha, but you get the idea, right? 4.5 nya erase alana so that we can answer 4.5. Okay, 4.5 again. Lana ke bathi, how many electrons does an ion of element P have? Draw the Aufbau diagram of this ion, right? So lana bathini ke thi, bathu element P, now element P sim identify sato element P uyini sodium, right? It's sodium. But it's through a Aufbau diagram for element kabani ka P. The ion of element P is what? Is Na plus 1. Since metals they all lose electrons during a chemical reaction. So now elements in group 1 sodium, for example, you lose an electron L1, so uzoba nobani no plus 1. Therefore the Aufbau structure nasige, or the diagram begagela sibanani nama energy levels. On the first energy level is taller the s orbitals, and then on the second energy level is taller and ama p orbitals, right? So therefore sibana nalogu, and then sodium ion una 10 yama electrons. The element has 11 electrons, since you lose 1 electron yosala 10 yama electrons. So there's a rule esisebenzisayo uma si draw ama Aufbau structures or Aufbau diagrams. Si sebenzisa what we call Hans rule, right? Sithini sifila in ama orbitals, sifila in ama electrons wethu on each orbitals, right? And senza sure ukuthi nasifila lawo ma electrons lawo siwafaka individually before siwaphera lawo ma electrons. Ngichaza ukuthini? First energy level, second energy level, p orbitals angisho. Alright, second energy level, bheka ke manje. First energy level, electron angisho, it's going to be an electron lana, and then lama electrons, they must have ama opposing spins angisho. Lama electrons aspina in opposite directions. So bheka, first energy level, s orbital yokuqala ngifaka 1 electron, bese ke angipheri just yet, but I'm going to the second s orbital ngifaka an electron, bese ngiyabuya ke ngifaka electron with an opposite spin, ngifaka another electron with an opposite spin. So sengi allocate ama electrons i4, meaning sele ama electrons ayingaki i6. So for the p orbital 2, kuyoba 1 1 1 1 1, therefore it's 2 4 6 8 10, right? So wonke ama orbitals wethu are filled in for the Aufbau diagram of this ion. If besdraw iloga Aufbau diagram for sodium for iloganj, for the element, not the ion, besoba nenye orbital lapha phezulu, right? Besoba nenye orbital lapha phezulu. But anyway, this is the Aufbau diagram 4.5. So 4.6, when orbitals of where am I going? Oh, okay. When orbitals of identical energy are available, electrons are placed in individual orbitals before they are paired. Give the name of this rule. It's the rule esisebenzise phezulu, 4.6 Hans rule. And then siyaku 4.7. Element Y occurs as these isotopes in the following proportions. Y 28 neutrons are with a percentage of 92.23%. Another isotope, say taller laubani, 29 neutrons, 4.68%, and then an isotope with ama neutrons out 30, the percentage yakhona. Now, but it's calculated the relative atomic mass of element Y. The relative atomic mass, okay, the calculation li very simple. It's just that 9 to kwamele uyenzeke la, kwamele uthi 28 the number of neutrons multiply ngale allocated percentage yakhona 92.23 uthi plus, then you do the same thing for lawa manye times 4.68 plus okay, I think fuck my brackets la, plus I don't think ngizoba ne spaces enough la, but let's try 30 times 3.09%. Then divide everything. Then you will divide everything by 100% equal to kanjalo nje free 3 marks. Ma marks wa mahala la. Ma marks wa mahala. 23 plus 29 times 4.68 plus 30 times 3.09, and then you divide that by 100, which is equal to, in as you round it off to 2 decimal places, then the answer you to give about 28.11. Yes, this is our final answer, Euler. So this is our final answer. This is the relative atomic mass of element Y, and the final question for our question 4. I hope we enjoyed this video. Ungakhohlwa uku-like, ungakhohlwa uku-subscribe, ungakhohlwa uku-share, ungakhohlwa uku-leave a comment nangabe une-question or ufuna uku-add something or ubona ngenza i-blunder somewhere kuma-calculations wami. Please point it out ngoba inceda namanye ama-viewers on this channel as well. So yeah, thanks for tuning in. In the description box uzothola ama-links for other videos engiwarecordile. So for now guys, asibonane on the next video, and bye bye.